Okay, for number 4, I'm actually going to type in, instead of h equals negative 16 squared plus 1,250, I'm going to do y. So y equals negative 16, just because it's easier to make a table that way. So negative 16x squared plus 1,250. Okay, so this one is dropping a penny off the Empire State Building, and it wants to know how long it will take a penny to strike a 6-foot tall person. Okay, so if you look at this, so we can zoom out, see how tall that is, but that makes sense because it's 1,250 feet high that the penny's being dropped from. So let's actually go back and zoom in, because what I want you to see is I want a height of 6. So all the way up at the top, it would be 1,250, but I want to know when it hits somebody at 6 feet tall. So here's 6. Let me zoom that in, see if I can get it to show 6 for us. There's 6. So I'm going to try to get right there, bam, on that line. Right there. Okay, so 6 feet tall. Let me see if I can get it. Oh my gosh. So right about there, it looks like 8.817. Okay, so I'm going to write that down. 8.817 as a reference point right now. Okay, so it seems like it's going to take 8.817 seconds. So let's make a table. And in my table, I have X values of all these, but I want 8.817. So I'm just going to add one. 8.817. Okay, that is almost about 6 feet, isn't it? It's a little bit over 6 feet tall, so I know I'm correct. So what I'm actually going to do is on this one, so I have the equation h equals negative 16t squared plus 1,250. I'm using Desmos to help me, but I'm also going to do this by hand. How long would it take? So what is the time for the penny to strike a 6-foot tall person? Put 6 in for the height. And you can definitely solve this. So subtract 1,250, subtract 1,250. And I'm going to go over here a little bit. We get negative 1,244 equals, negative 16t squared right there. Okay, so let's divide by negative 16. Divide by negative 16. So 1,244 divided by 16. I'm not doing the negatives. I get 77.75 equals t squared. And then I square root it. Let's square root it and see what we get. Okay, so take the square root of 77.75. Oh, and I get 8.8175. I don't know if you can see. So 8.817596. 7596. Okay, so I was really close. So let's do that. 8.817596. Look how close I'm getting to 6 feet. Okay, now we can just approximate it because nobody's going to say that many seconds to that many decimal places. So we really truly are just going to say 8.8 seconds. Okay, so after about 8.8 seconds, that penny will hit a 6-foot tall person. All right, let's go to the fireworks one. So again, I'm going to put these as X's and Y's because it just makes it easier. Let me clear this out. On Desmos to get a table. So y equals negative 16x squared plus 80x. Okay, so let's read the question. It says, how long will it take the fireworks to reach the ground? Okay, well, this one's a little bit easier because I just want to know it came up. I just want to know when it hits the ground. So bam, you just have to hit on the ground right there. Oh, wow, height is 0, 5 seconds. So it takes 5 seconds for the fireworks to reach the ground. Okay, so some of these are easier than others. All right, the Apollo's chariot, a roller coaster at Busch Gardens, blah, 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 blah. Here's the equation. So let's enter the equation. So what do I have here? Y equals negative 16x squared plus 101x plus 10. Okay, so there's my equation. Let's see what the question is asking. What is the maximum height reached by this ride? Okay, maximum height. I just have to zoom out a little bit. And let's get to that height. Let's go. Where's it at? All the way up here. I have to find the vertex. Getting closer. Getting closer. There we go. Okay, so the maximum height would be up here at the top. Click on it, and I get, so it's 3.156 seconds that it takes to get there, but I have a maximum height of 169.391. So 169.391 feet. That's how high it goes up. Okay, it takes 3.156 seconds to get there, but that's not the question. Okay, Ava is jumping on a trampoline, so let's go ahead and throw that one in there. So negative 16t squared plus 20x plus 6. Okay, so let's hit the home button. Let's see where we're at. Okay, so the question says, would Ava reach a height of 14 feet? Okay, so does she go 14 feet? Let's check and see if she goes 14 feet. Let's check her maximum height. Her maximum height is at the vertex. Click on it, 12.25 feet. So at 0.625 seconds, not even a second, she has jumped 12.25 feet. Did she reach 14 feet? The answer is no. 12.25 feet is her maximum height. So she did not reach 14 feet. Okay, so let's go to the last one. An astronaut on the moon throws a baseball upward. The equation of the baseball pathway is right here. The same experiment is done on Earth. In which pathway is modeled by the equation? How much longer would the ball stay in the air on the moon compared to the Earth? Okay, so let's type in both of these. So negative 16x squared. Oh no, sorry, the moon has a different, and so it does it. All right, negative 0.8 x squared plus 10x plus 2. Okay, so there's that one. I'm going to zoom out just a little bit just so I can see the whole thing. Okay, so there's that. So remember, that first one is on the moon, and let's do on the Earth. Okay, so y equals negative, and it's 4.9. 4.9 x squared. So remember, this one's in blue, plus 10x plus 2. There we go. Okay, so let's see where this one is at. Okay, so this is the moon. This is the Earth right here. Okay, so let's see what the question is. It says, how much longer would the ball stay in the air on the moon compared to the Earth? So we need the total time for both. Okay, so the total time would be, look at my cursor right here. The total time would be, how long does it take for it to come back down? How long does it take for it to come back down? So let's do the times when it hits the ground. Okay, so the time here is 2 point, that's on Earth, right? And the time here is 12.697. 12.697. Okay, so that is on the moon. So all you have to do is subtract those. 12.697 minus 2.224, and we get 10.473 more seconds on the moon than on the Earth. Okay,